Hello there, this is our next section in the Blitzer combo book for beginning and intermediate algebra. We're now on section 1.2, which covers fractions in algebra. So today, we'll be converting between mixed numbers and improper fractions. Write the prime factorization of a composite number. Reduce or simplify fractions, multiply fractions, divide fractions, add and subtract fractions with identical denominators, add and subtract fractions with unlike denominators, and solve problems involving fractions in algebra. So why don't you guys go ahead and pause the movie and start with the warm-up. So let's see how you did. We're evaluating these algebraic expressions at the given values. So in the very first one, what we want to do is wherever we see an x, we're going to be plugging in a 4. So there's an x here and an x here. Let's see how you did. We'll have 3 times 4 minus 8 all over 5 times 4 minus 1. And again, this is where the x's were before. And here we need to multiply first, so we'll get 12 minus 8, all divided by 5 times 3. And this will yield a result of 4 over 15. And we're all done. Put our happy box around our answer. Now that one didn't quite connect. Let's check it out here. There we go. All right, how'd you guys do? Pretty good? Okay, let's see what happened with this next guy. So here we've got 2 different variables. We've got an x, which will take on a value of 0. We've also got a y, which will take on a value of -2. So here we are. This will be 6 times 0 minus 2 times -2 increased by 5. That's going to yield a result. Again, this is where the value for x was plugged in, and this is where the value for y was plugged in. So then any number times 0, remember, is 0. And then we'll get minus a -4 plus 5. This here is really the opposite of -4, which is +4 plus 5, which is 9. How'd you guys do on that one? Pretty good? Alrighty, well, here we go. Now we're getting to our, start of our vocabulary. Very important to know the vocabulary in math. I mean, if you think about if you've ever taken Spanish or French, another foreign language, you have to learn your vocabulary. Otherwise, you're spouting nonsense all over town. So here's the, foreign language of math. So numerator, the number or algebraic expression that is written above the fraction bar. Denominator, the number or algebraic expression that is written below the fraction bar. Natural numbers. Natural numbers are like your counting numbers. So here, the numbers that we use for counting. It's important to know the different number groups because they're used in definitions for other things. Mixed numbers. Okay? So a mixed number consists of the sum of a natural number and a fraction expressed without the use of an addition sign. Okay, so, these numbers are kind of tricky here. We're going to segue down here real quick and show you an example of a mixed number. So here, if you have, let's just say we have 1 and 3/5. Okay? What this really means in mathese is 1 plus 3/5. There's an implied addition sign when you have a natural number with a fraction right next to it, as long as there's no parentheses around that fraction. Okay? So let's come back here to the definition for improper fractions, and let's just kind of highlight so you can, this is a mixed number. All right, so improper fractions. An improper fraction is a fraction whose numerator is greater than its denominator. Such as, I don't know, 17/5. Okay. All right, so let's check this out. Let's take a look at how we could convert a mixed number to an improper fraction, and then we'll be checking out how we would convert an improper fraction into a mixed number. So why don't we take our old friend here, 1 and 3/5, right? Here we just said that we have 1 and 3/5 is the same as 1 plus 3/5. But in order to, add a fraction to a natural number, what we need to do is we need to multiply by 1. Okay, you can multiply any number by 1 and you still get that number back. And the one that we will pick is 5/5, because 5/5 will give us the same denominator. So do you guys see that here we will now have 5/5 plus 3/5? And this is going to yield a result of, we can make one happy fraction now that we have the same denominator. And then you just add your numerators. And at the end of the day, we will get 8/5. Okay. So now that we've looked at an example, let's look at steps for doing this. So first, we multiply the denominator of the fraction by the natural number and add the numerator to this product. So if you come back and look at what we did, all right, in this step here, we multiplied the denominator, right? This was a different way of showing you why it works. But do you see that the denominator was 5? We multiplied the denominator times the natural number, and then we added this numerator 3. So there's the steps that you're shown here are kind of a shortcut way. You can always use the way I showed you as kind of a default way. All right, so here you place the result from step 1 over the denominator of the original mixed number. All right. So let's take a look at the one that we had, 1 3/5, and show you how to convert this using this method. So the denominator is 5. We're going to multiply that to the natural number. We're going to add the numerator of the fraction, and we're going to place it all over the denominator 5. And this is going to yield a result of 5 plus 3 all over 5, which of course gives us our 8/5. So that's using the shortcut method. All right. Now you try. Here's a couple of examples. Go ahead and pause this movie and work out these examples. All right, so here we go. I'm going to work this one out, and you can check and see how you did. So we'll get 40 plus 7 all over 8, which is 47/8. And we put our happy box to show that we're done. Okay, next up we've got the denominator 11 times 2 plus that numerator all over 11. This will give us 22 plus 5 all over 11. And then we'll get 27/11. How'd you do? I bet you did really well on that one. Okay, so next up, sometimes we want to convert an improper fraction to a mixed number. So here, really what you have is a division problem. I mean, if you think about it, let's just say you had, something like, I don't know, 8/3. How about that? Well, 8/3 means 8 divided by 3. 8 divided by 3. All right? So what you can do here, remember, the dividend goes in the house, the divisor goes outside the house. How many 3's are in 8? I believe we've got 2 3's in 8. Then you do 2 times 3 is 6. Subtract. We're going to end up with a result of 2. So this is 2 remainder 2, which is 2 2/3. And you know what? Let me put this 2 so it doesn't look like it's in that denominator. All right? So let's go ahead and put the steps down. All right? So here, divide the denominator into the numerator. Record the quotient, which is the result of the division, and the remainder, write the mixed number using the following form. You've got your quotient, and then you have your remainder, and that's going to be over the original denominator. So here, with the problem that we just did, the quotient, I don't think that yellow will show up. Let's see, the quotient was this 2. the remainder, that's going to look weird, that color. Let's try, well, we'll open up some other colors. We'll branch out here. So let's take a look at maybe this purpley one. The remainder, you know, I apologize. We're gonna underline because these numbers are getting, or these colors are getting strange from the so this is the remainder we were talking about, and this here is the original denominator right there. Okay, so let's check it out. You go ahead and try these guys. Go ahead and pause the movie and try these guys, and then you can check and see how you did. Okay, so, oh, and remember, you're supposed to be pausing the movie as we go. So this one is going to be 15 divided by 2. So 15 divided by 2, there are 7 2's in 15, and we get a remainder, or not a remainder of 1. So that means that 15 halves equals the quotient 7 and 1 over 2, or 1/2. All right, here we go. The 24 is the dividend, goes in the house. We've got the 7 outside the house, that's our divisor. How many 7's are in 24? I believe there's 3 7's in 24. Subtract out that 21, and we'll get a 3. So here, that means that we found out that 24 7's is equal to 3 and 3 7's. Okay, next up, factors and prime factorizations. Very useful, these here, you know, we're going to be working with natural numbers right here. What you're going to want to learn this really, really well, because we learn about factors and factoring throughout the course. So this is a skill where if you really master it when we're talking about the natural numbers, you're going to have an easier time later on in the course. Okay, so fractions can be simplified by first factoring the natural numbers that make up the numerator and denominator. To factor a natural number means to write it as 2 or more natural numbers being multiplied. So here's some more vocabulary. Prime number. A prime number is a natural number greater than 1 that has only itself and 1 as factors. Composite numbers. A composite number is a natural number greater than 1 that is not a prime. All right, here's something important. Every composite number can be expressed as the product of, what do you think? What do you think? You got it? Prime numbers. Very important. That's why it's in capitals. Expressing a composite number as the product of prime numbers is called the prime factorization of that composite number. So here's the next example. 128. We want to find the prime factorization of the following numbers. So I'm going to show you two different methods of doing this skill or performing this skill. One thing you can do is you can take your number. This is actually the way I prefer it. Put a little box here and think to yourself, okay, it's an even number. So every even number has a factor of 2. So 2 times 64 equals 128. So there's one of our factors. Now the 64. 2 times 32 is 64. We still have an even, so you keep going along. And the beauty of this method is that all of your prime factors are lined up outside these boxes. All right, so we'll keep going. I'm running out of room. We'll continue it up here. So we have our it's going to be a 2. Do you see that over here? And then 2 goes into 2 once. So basically here, all of these guys are the prime factors of 128. So what have we found out? 128 equals 2 multiplied to itself 1, 2, 3, 4, 5, 6, 7 times. 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. This could also be written as 2 raised to the 7th power. So these are both correct. Now, a lot of times people learn using factoring trees. So 54, if you think of, two numbers that multiply to be 54, you might have thought of 6 and 9. Now, neither one of these are prime, so we're going to keep going. You make a product of 6 using 2 and 2 times 3, and now notice you've got prime, so we'll go ahead and circle them. Now 9 is 3 times 3, so now we'll have our complete factorization because we have all prime numbers. So 54 is equal to 2 times 3 times 3 times 3, or how else could we do it? 2 times, how many times is 3 multiplied to itself? You got it, 3 times. So either one of these would be correct for the prime factorization of 54. Okay, so now this leads into reducing fractions. So two fractions are called equivalent if they represent the same value. Writing a fraction as an equivalent fraction with a smaller denominator is called reducing a fraction. A fraction is reduced to its lowest terms when the numerator and denominator have no common factors other than 1. Okay, fundamental principle of fractions. The value of a fraction does not change if both the numerator and denominator are divided or multiplied by the same non-zero number. So, if we have A times C over B times C, that's the same as A over B. So, okay, let's look at an example. Suppose that we had 2/4. Do you see that we could write 2/4 as 2 times 1 over 2 times, well, you know what, I want to do it in the same order as the example. So we could write this as 1 times 2 over 2 times 2. So the C in this example is this 2 here. So this C is, this 2 here is like the C. So what would we get? This means that this number 2/4 is equivalent to 1/2. Okay, so let's check it out. Here's our steps. Write the prime factorization of the numerator and the denominator. Divide the numerator and the denominator by the greatest common factor. What that means is it's the product of all of the factors that are common to both. All right, so if you had, for example, let's say we had 21 over 28. The greatest common factor of this one would be 7, because 21 is 3 times 7 and 28 is 4 times 7. So that would yield a result of 3/4, because the 7s would divide out. 7 goes into itself once and you end up with your 3/4. Okay, so let's check it out. 18, right? So 18, how could we write 18? Well, 18 we could write as 2 times 9. And 27, do you see, is 3 times 9? So here, 9 goes into itself one time in each of those, and at the end of the day we get a result of 2/3. Now here I didn't do the complete prime factorization of each of these because I recognized that 9 was a factor of both 18 and 27. And there's a trick for 9s and for 3s actually. Do you see that the digits in 18 add up to 9? 1 plus 8 is 9. So if the digits of a number add up to 9, then 9 divides that number. See, 2 plus 7 is 9, so we know that 9 will divide 27. The same thing goes for 3s. Over here, 4 plus 5 is 9, and I know that 3 divides 45 because 3 divides 9. What else divides 45? You got it. 9 divides 45 because 4 plus 5 is 9, and 9 certainly divides 9. Okay, so let's check it out. Here, think about 100. Any number that ends in a 0 or a 5 is divisible by 5. So I'm going to start by looking at, let's see if 5 will work. So how many 5s are in 100? I think there's 20. Good. 20 5s are in 100. And then how many 5s are in 45? I think it's 9 5s are in 45. So again, 5 goes into itself once in each of these, and we end up with 29s. Now, I know in your previous math class, your teacher was very strict about having you change improper fractions into mixed numbers. We don't need to worry about that unless you're specifically asked for the mixed numeral. I'm totally happy with a reduced improper fraction. Okay, so we can put our happy box around that answer and we're good to go. Okay, next up, multiplying fractions. Multiplying fractions. The product of 2 or more fractions is the product of their numerators divided by the product of their denominators. So if we had some fraction, a over b, and we're multiplying it by another fraction, c over d, this is equivalent to a times c over b times d. So let's check out an example. Here, this first one, we can write this as one happy fraction. We can say, oh, this is 16 times 33, all divided by 11 times 2. Now, hold on. Don't multiply all those out. What we want to look for, now that we've got our one happy fraction, we're going to try to reduce these fractions. Now, do you see that we can write, I'm looking at the 2 and the 16. They're both even, right? So here, and you'll get faster at this and you might not be writing all these steps. And if you're getting, the correct answer for the right reason, you're good to go. But here I'm going to write out what we just learned. So 16 we could write, couldn't we, as 8 times 2? So the 16 I've written as 8 times 2. The 33 we could write as 3 times 11. I am doing that because I see this 11 down here. So 33 was written as 3 times 11. That's all over 1 times 2 from that 2 times 1 times 11 from the 11 in the denominator. And notice what happens. Beautiful things. 2 goes into itself one time in each the denominator and numerator, and 11 will divide out. And at the end of the day, we will get 8 times 3 over, 1 times 1 times 1 times 1, which of course is just 24 over 1. 24 divided by 1, well, there's 24 ones in 24, so our end result is 24. Now, why don't you try this one? I'll give you a little hint. This one is equivalent to 5/8 times 12 over 1. Any natural number can be written over 1. So pause the movie and see if you can get this bad boy. Okay, let's see how you did. So this is going to be 5 times 12 over 8 times 1, which will give us 5 times, I'm looking at 12 and 8. What's the largest number that divides both of them? You got it. 4 divides both. So I'm going to write 12 as 3 times 4. 8 times 1 is just 8, so I'm not going to worry about that 1 there. And I'm going to write 8 as 2 times 4. So here, the 12 is the 3 times 4, and the 8 is written as 2 times 4. And again, 4 goes into itself once, and we will end up with 5 times 3 times 1 over 2 times 1, which is 15 over 2, 15 halves, and we're good to go. How you doing so far? Math is awesome, isn't it? Okay, dividing fractions. The quotient of two fractions is the first fraction multiplied by the reciprocal of the second fraction. So just a little reminder here, the reciprocal, let's just say that you had 2/3, all right? The reciprocal of 2/3 is that fraction flipped. Basically, you're looking for the number where if you multiplied 2/3 times that number, you would get 1. All right, so that, of course, will be 3 halves. The easiest way to remember is that you flip the fraction. Okay, so here we go. If we have A over B divided by C over D, that's equivalent to A over B times D over C. So, and that, of course, is going to follow the rules for multiplying fractions. So you have to do an adjustment first. I mean, nothing in math is free. So in order to change that operation from multiplication or from division to multiplication, you have to flip the divisor, the second fraction. All right, here we go. This is going to be, we have 25/32 divided by 3/4. So what do we do first? That's right. We change the division symbol to a multiplication symbol, and to pay for that, we have to flip that second fraction. So we have now changed this to multiplying by the reciprocal. Well, now we'll have 25 times 4 over 32 times 3. So let's kind of step up our game a little bit. Instead of completely factoring each time, one thing a person could do is this. You could say, 4 goes into itself once, and it goes into 32 8 times. Right? So, and if you need to go back, keep doing it the other way, that's just fine. All right? This is just, we're going to start stepping things up a little bit. So this will yield a result of 25 24ths, because 8 times 3 is 24. Okay? All right, now be careful. What did we do before with that 12? Remember, 12 is the same as 12 over 1. So here, we're going to get 144 thirds times 1/12. Now, some of you might have been able to recognize that 3 divides 144 because 1 plus 4 plus 4 is 9, so 3 will divide that 144. So if you had reduced this fraction first, the 144 thirds, that's just fine. But I'm going to go ahead and continue on this way since I started it out this way. So here we go. This is 144 times 1 over 3 times 12. Now notice that we can certainly divide out a 12 from the 144. 12 goes into itself once, and into 144 12 times, right? So here you end up with 12 thirds. But what's 12 divided by 3? You got it. 12 divided by 3 is indeed 4. So you're all done. Great. All right, so let's move on to adding and subtracting fractions with identical denominators. Right? So the sum or difference of two fractions with identical denominators is the sum or difference of their numerators, and we place that over the common denominator. Okay. So if we had a over b plus c over b, we would get a plus c all over b. And if we had a over b minus c over b, you got it, we'll have a minus c all over b. So why don't you guys try the next one? Oops, sorry, I see a little typo here. My bad. This, of course, would be the first one. All right, so let's see how you did. We have, this will be 5 plus 3 all over 6 because the operation is addition and they have common denominators. And then this is 8 over 6. Are we all done? No, always look. I mean, definitely if they're both even, we know that we can divide out a 2. You see that? So 2 goes into 8 4 times, and 2 goes into 6 3 times. So at the end of the day, our result is 4 thirds. Okay, let's see how you did on number 2. We can write this as 11 minus 10 all over 13, which yields a result of 1/13. And that one is fully simplified, so we're all done. All right, so now we get our adding and subtracting fractions with unlike denominators. The value of a fraction, remember, does not change if the numerator and denominator are multiplied by the same non-zero number. So let's work on equivalent fractions real quick so that we can, extend that skill into adding and subtracting fractions with unlike denominators. So 5/8 times something over something, and we want to get 32 as the denominator. So we're looking to see, what number, over what number we would use. Well, 8 times what is equal to 32? Good. 8 times 4 is 32. But we have to balance that out. Remember, nothing in math is free, right? So in order to balance it out, we have to put a 4 here because 4 over 4 is 1. So, and that's it's like we just changed our outfit. We didn't change who the person was. So the number now that's got to go over 32 is 5 times 4, which is 20. So 20 over 32 and 5/8 have the same value. Notice if you reduce 20 32nds, you would get 5/8. So the least common denominator is the smallest number that the numbers in each denominator divide into. It's useful to find the least common denominator instead of just multiplying the two denominators together like a lot of, that's one method. It's okay. But the thing is that if you get the smallest common denominator, there will be less reducing, less simplifying that you need to do at the end. So here's some steps for adding and subtracting fractions with unlike denominators. Okay. Rewrite the fractions as equivalent fractions. With the least common denominator. Add or subtract, depending what the operation was, the fractions, putting this result over the common denominator. Now, sometimes, sometimes it's not that hard to find, or sometimes it is hard to find the LCD. So here's a skill you can use. It's called using prime factorizations to find the LCD. So you find the prime factorization of each denominator. The LCD is obtained by using the greatest number of times each factor occurs in any prime factorization. So here we go. We're going to use that method for number 2 because it's going to be a little more difficult to find the least common denominator for the second one. But in the first one, look at the denominators. The denominators are 7 and 14. So what do you think? Is 7 one of the factors of 14? Yep, you're right, it is. So here, if I did this, so I'm going to write my 23/7. I'm going to leave a space. Now 14 is going to end up being the common denominator because 7 is a factor of 14. So do you see, If we multiply 7 by 2, we'd get 14. And then we have to pay for that by putting a 2 in the numerator. So our equivalent fraction that we obtain, 23 times 2 is 46 over 14. That's equivalent to 23/7. And then we're going to be adding 5/14. And then using the rules learned before, we'll have 46 plus 5 all over 14, which yields a result of 51/14. Okay. Great. Okay, here we go. Number 2. We're first going to explore the prime factorizations of the denominators. So 12, all right? So, you use whichever method you like. I'm going to use my little boxes. So 2 times 6 is 12. 2 times 3 is our 6. And then 3 and 1. So 12 equals 2 times 2 times 3. So 2 occurs twice and 3 occurs once. Now 15. So I know that 3 divides 15, so 3 times 5, and then 5 times 1. So 15 is equal to 3 times 5. So the LCD, you have to include all of the factors that show up, and if they have factors that overlap, you just put the most times that it occurs. So our LCD is going to be 2 times 2, because 2 occurs twice there. 3 just occurs once in each of them, so we'll just put it once. 5 occurs once in this guy. So our LCD will be 2 times 2 times 3 times 5, which is equal to 60. So now 5/12, so I'm going to leave a space, minus 2/15. We're going to have, this one's going to have to be adjusted by 12 times what equals 60? Good. 5 over 5. What about this next one? 15 times what number is 60? Great. 4 times 15 is 60. So now we will have 25/60 minus 8/60, and then we can make one happy fraction, 25 minus 8 all over 60, and then that's going to be 17/60, and check to make sure it's reduced. Yep, it is. So you put your happy box, you're all done around that result. Very good. How you feeling? Okay, next up. Like I said before, math is a foreign language. Okay, math is a foreign language. So here, what we have going on is we need to take these English phrases, and we're going to translate to an algebraic expression. We're translating English to mathese. And we're going to go ahead and just use x as the variable. So you just break it down. A number. Well, a number, what could we call that? How about x, like the directions said? So a number translates as x. Decreased by, remember that was one of the words for subtraction. Decreased by. So this part, decreased by, is the minus. 1/3 of itself. 1/3 of itself. So though the 1/3's not so bad, right? 1/3 is just 1/3. What does of mean in math? Good. Times. And then itself would imply the same number. Good. So 1/3 of itself would be 1/3 times x, or just 1/3 x. So this part, 1/3 of itself, is represented by these symbols. Okay, go ahead and pause the movie and see if you can get this next one. All right, let's see how you did. The sum of. So we're going to be adding these two things. Oh, let me get plugged in here. We're going to be adding these. Oh, good, we got power. We're going to be adding these two terms. We're going to be adding. So we'll start with this, the sum of. Okay, so when it works like that, you want to put the first thing on the left side and the other thing on the right side. So the sum of is our plus. So I'm going to kind of put it in the middle. Now we have to deal with this. So 1/9 of a number is going to go on the left side. So when the sum of, I'm going to put this with the sum of something and something else. So 1/9 of a number. Remember, we can say 1/9 times x. So 1/9 of a number is represented by this stuff. And then 1/10 of that number. 1/10 of that number. So 1/10 of that number would be 1/10 times x. Gives 15. So now do you see, instead of just an algebraic expression, I believe we have an equation. So gives 15. Let's go ahead. This purple's too dark, so let's go ahead and look at a different color here. This one here gives 15. Okay, gives 15. We're going to have equals 15. Very, very good. So we want to get back our purple again. Equals 15 is equivalent there. How'd you do? Uh-oh, we forgot our happy boxes here. So this is the end result here, and this is the end result here. Beautiful. Okay, so here's an application that I got from the book. We basically have a musical scale going on. Oops. So the value of these notes, all right, so I don't know what your music background is. There might be a little flaw here because I had a student that said that there were some issues, but we'll take it for what it is. Here we go. So musical scale, we've got these are the values of the notes. Okay, these are the values of the notes, and what we want to do here is we have a standard line. We have a line from the music sheet for an Irish melody or lullaby. So here we go. Shown below is a line from the sheet music for an Irish lullaby. The time for this one is 2/4, which means that each measure must contain notes that add up to 2/4. So we're going to just use a vertical line to divide an Irish lullaby so where the measures are in the proper spot. So let's add up these notes. These notes right here, okay, these little notes here are eighth notes. All right, when they're strung together, eighth notes look like this first one. So what we have is we have an eighth here, an eighth here, okay, and then this one is a fourth, okay. Now we're going to have an eighth, another eighth, I know it looks funny, and then an eighth, and you got it, an eighth. So is every time we get to 2/4, we want to separate the measure. So here, 1/8 plus 1/8, what would you say that is? I mean, if I was adding these up, do you see that I would get 2/8, and then I still have plus 1/4? But 2/8, do you see, reduces to a fourth. So we have a fourth plus a fourth. Oh, look what happened. We have now 2/4. So do you see over here we end up with 4/8, right? Which, if we were to divide out a 2 from both the numerator and denominator, do you see that that would be 2/4? So the skill here wasn't completely reducing the fraction, it was figuring out when we hit 2/4. So here what we would do is we would draw our line here to separate the measures. Okay? And I know this was a long one, but we're all done. We have conquered our fractions in algebra. All right, have a fabulous day and make sure you do your homework. Bye.